Hi everyone, welcome to this lecture series on Oracle Cloud Infrastructure Fundamentals. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we will look at the physical OCI architecture and look at how it enables you to create highly available applications. So for the agenda for this module is something like this. We'll first look at OCI regions. What does a region imply? What are availability domains, a construct specific to OCI? What are fault domains? How can you design your own highly available applications? And then what is this concept of compartments, which is again a unique OCI construct? Today we have 21 regions live around the world, and we also have 15 announced regions and planned for to go operational later this year. So by end of 2020, Oracle Cloud Infrastructure is going to have a global footprint of 36 regions worldwide. And you can see some of the regions which are live today, commercial regions here around the world. You can see some of the planned ones. You can also see some of the government regions available to some of the government customers. And we also have a partnership with Microsoft where we connect some of our regions to Microsoft Azure. And you can see some of those regions here on the map as well. Now let's zoom in some of the details on the physical architecture of OCI. So the first one concept is, what is a region? A region is a localized geographic area comprised of one or more availability domains. So think of regions as a metropolitan location, metropolitan area. Within a region, you have this concept of availability domains. These are one or more fault tolerant, completely isolated data centers located within a region but connected to each other by a low latency, high bandwidth network. So within a region, you have three availability domains, and as you can see, they are connected uh, by a very low latency, high bandwidth network. Now, within an availability domain, you have this construct called fault domains. Fault domain is a grouping of hardware and infrastructure within an availability domain to provide anti-affinity. Sometimes we also refer to these fault domains as logical data centers within an AD, and we'll look into all these in subsequent slides. At a high level, this is what the physical OCI architecture looks like. Physical architecture comprises of regions. Regions are comprised of availability domains, and availability domains have fault domains. Now we also have this concept of one AD region, one availability domain region. OCI has chosen to launch regions in new geographies with only one AD to increase our global reach quickly and optimize for reaching as many customers worldwide as possible. We are launching regions which have only one AD. Now, for any region which has only one AD, a second AD or region in the same country will be made available. We have committed to making it available within a year to give you options for disaster recovery and data residency. So for example, you can see some of the regions we launched in the beginning have three ADs in the US, in Europe. Now the regions we are launching now have one ADs, but still what we are doing is we are giving you this idea of region pair. So in every geopolitical area you will have region pairs, like in US you have two regions, in Australia you have two regions, Japan, and so on and so forth, so that you can still comply with your local regulatory and data residency requirements, but you could still do things around disaster recovery, and we'll talk about that as we go and talk about HA designs later on. So how do you choose a region? It's rather straightforward. You choose a region based on location. You want to be closest to your users. Why? You want to give them lowest latency and highest performance. Makes sense. You want, many times you have data residency and compliance requirements. Many countries have strict requirements around data residency. Your data cannot leave the country. European Union is a good example, and so on and so forth, many places. So you will choose a region to comply with your residency and compliance requirements. And sometimes your choice is also dependent on service availability. Now, we commit to making new cloud services available in every region worldwide. But sometimes we make these available based on regional demand, regulatory compliance, resource availability, and so many factors. So it is possible that we launch a service first in a few regions and then we roll it out to other regions. So these are some of the key considerations you will have when you have to choose a region. Now let's really zoom in and talk about some of the constructs we looked at earlier, specifically availability domains and fault domains, because we talked about regions, what regions are, 180 regions, how you choose a particular region. So now let's talk about availability domains. Availability domains, as we talked about a few slides back, are data centers completely isolated from each other, fault tolerant, and very unlikely to fail simultaneously. So what happens in ADs, they don't share physical infrastructure such as power and cooling. They don't share internal network. So what happens is if a failure in an AD is unlikely to impact the availability of the other. So what do I mean by that? Well, if you look at the region here, this particular region is a multi-AD region, and you have three ADs as we talked about. So AD1, AD2, AD3. If AD1 is unavailable for some reason, your AD2 and AD3 are still operational. This might happen because, let's say, there is a power failure in that whole AD. Though we have several mechanisms to prevent that from happening, but let's say there's a power failure, there is flooding, there is natural disaster like an earthquake or something, right? So it just impacts that particular AD. It might be unavailable, but your other availability domains are still up and running and available. So that's all pretty much on availability domains. What are these things called fault domains? Well, each availability domain has three fault domains. Fault domains act as a logical data center within an AD. Usage of multiple fault domains reduces correlation of failures within an AD. We'll look into what that means. Resources placed in different fault domains do not share single points of hardware failure specifically. So things like physical servers, physical rack, top of rack switches, or power distribution units, these fault domains do not share. Now, what does that mean? Let's look at the previous example. We have a region here. We have three availability domains. Each of these availability domains has three fault domains. So you can see fault domain 1, fault domain 2, fault domain 3 here, so on and so forth for availability domain 2 and availability domain 3. If fault domain 1 is not available for some reason, you still will have fault domain 2 and fault domain 3 running. So literally what we have done is in a region, first we had these availability domains which were data centers, physical data centers, and we carve out logical data centers within them, and we are giving you three logical data centers within each of these ADs. And there's a whole complex set of things we do to make sure that services are always up and running. And this is a fundamental course, so we are not talking about those, but just to give you an idea, um, the control plane and the data plane we have running in every fault domain for every service. So even if a particular fault domain goes down, you still have your control planes and data planes running, and so on and so forth. There are lots of complex things we are sort of just avoid for this particular lecture. Now, when we change resources, we make sure that resources in at most one fault domain are changed at a point in time. So it will never happen that we do a configuration here and we do the software configuration here. We always roll it out one fault domain at a time. This means that any kind of availability problems caused by change procedure, which is totally up to us, on us, are isolated at the fault domain level. So it will never happen that we are trying to patch the hypervisor and the whole hypervisor for the whole AD goes down. We will isolate all this at fault domain level. And we have this concept of service cells and lots of complexity around how we actually architect around those. for we're not going through in this lecture, but we make sure that we isolate the faults, these kind of configurations, change procedures at the fault domain level. Now you as customers control the placement of your compute and database instances to fault domain, and you could choose that at launching. What happens to storage? We do that for you, and I'll talk about that in the storage modules. But you have a choice of using these logical data centers. The whole idea of a region having three availability domains, uh, and each availability domain having three fault domain is to give you this high availability construct and let you avoid single points of failure. So you should design your architecture to deploy instances. So what does that mean? You should design your architecture to deploy instances that perform the same tasks in different fault domains or in different availability domains. If you can leverage that, if you can leverage the multiple AD regions. What does that mean? Well, let's look at an example. So you have a region. Let's say you have one AD in that region, which are most of these new regions. You have three fault domains, which is always the case whether it's one AD in a region or multiple ADs in a region. An AD will always have three fault domains. Now, we haven't talked about networks and such, so we'll skip that for now. But let's say you create a virtual network here, and you have a virtual machine or an instance, an application talking to a database. So you have this kind of a setup, very simple setup. It can be, yeah, like a web app or something. You have an app instance talking to a database. Now, in this case, you have a single point of failure. If this application, this virtual machine dies, your application dies, or if this database dies, your application dies, right? So this is single point of failure. The fact we have ADs and fault domains in a region is to let you avoid these single points of failure. So how can you do that? First thing is you should always deploy multiple instances of the same type. So you have an application here, these are all stateless. So you actually have a second copy running. Running where? Running in the second fault domain. Don't put it in the same fault domain because this fault domain can be unavailable as well, right? So choose the second fault domain, and you could do that, as I said in the previous slide, when you are launching a compute instance or a database instance. You can choose your fault domain. And now, instead of having one database, I can use something called a real application cluster rack. And we have a managed service for that. So now you are running this rack, basically two copies of the database in a clustered environment across two fault domains. So now if any of these things go down, are unavailable, you still have your app available. So this is what I mean by saying avoid single points of failure. Now let's say you are in a geopolitical area where you get multiple ADs in a region, right? And we have some we saw in European Union, in North America, in US. So let's say you have a region which has multiple ADs. So in this case, you could actually take your design to the next level. So first thing you could do is AD2 has the same construct, three fault domains. You create your application in a highly available environment. So in this AD, your application is highly available, right? You have two copies here, you have two copies here. When any of these goes down, your still application is up and running, right? Now what you could also do is you could leverage this thing called data guard, which is again a managed service we offer. And this one does your replication of your database, for example. And you could have different modes: switch over, planned replication, unplanned replication, unplanned migration. And in this case, let's say if your whole AD1 becomes unavailable, you still have your application up and running because you're replicating your data, and your AD2, you're running the same application in your AD2, in another AD within the region. So this is what we mean by saying avoid single points of failure, and the fact we give you these constructs of fault domain, availability domain, is to help you avoid single points of failure and manage, design, create highly available applications. All right, so we looked into this in the previous slide. Same thing here. In this case, you have single AD. So again, make sure that you're leveraging fault domains, because these in essence are your logical data centers within your single ADs. All right, so just to recap what we just went over, now let's go from the opposite direction when we looked at the region, availability domains, and fault domains in few slides back. So in this one, first start with fault domains. What are fault domains? Recap, they protect against failures within an availability domain. So for some reason, if there is a failure in set of racks, you can still have, or set of infrastructure, you can still have your applications up and running, leverage them. You have a choice when you instantiate your compute and database instances. You could actually leverage fault domains. In essence, these fault domains give you a logical data center within your availability domain. Then you have the concept of availability domain, which protect from entire AD failure, entire data center failure. So there's an earthquake, there's a natural disaster, yeah, something gone wrong here. So you can still, if your region has multiple ADs, your application can still be highly available. And then we have this concept of a region pair. Um, Available in some regions worldwide, and coming soon in the other regions, where if a whole region is unavailable, you can still move your applications to the another region, copy your data as such, and you can still recover from that disaster, and you can still maintain your data residency and compliance requirements. And on top of that, we also have SLAs on availability management and performance, so you can also leverage SLAs around these constructs. All right, so let's look at one last thing, design considerations, which is not really a physical design construct within OCI, but it's rather a logical design construct called compartments. What do we mean by compartment? Well, compartment is a logical collection of related resources. It helps you isolate and control access to your resources. Remember, it's logical, it's not physical. So what do I mean by that? Now, we are not talking about data centers and grouping of hardwares, fault domains, etc. Right? We're talking logical construct. So logically, you have an account. Your tenancy is nothing but an account. Tenancy is also called a root compartment, and I will talk about what that means. So you have lots of resources running in your cloud environments, right? Let's say you have a bunch of network components, and you have a bunch of storage resources, right? You could logically compartmentalize them in different compartments. For why would you do that? Well, you want to isolate your resources, maybe, right? You want to have different resources go in different places. You want you want to control access, so not everybody should have access to your networking resources. Very few people should have. Same with storage. So you have different requirements around who you want to access these resources, right? So you could create compartments, and you could start putting these resources in these compartments. You have compute resources, which actually might go in a completely separate compartment. The great thing here is, look at this example. You can nest these compartments up to 6 levels deep. Now you might look at all this and say, well, this seems more complex. Why couldn't I just put everything in my root compartment, my tenancy? Yeah, of course you could do that. It's not a best practice. Why? First, because you want to isolate your resources. You don't want to put everything in like one place. And the related reason is, you want to control access. You want to give access to only specific people to specific resources. If you put everything in one place, literally you are opening up all your resources to every user within your environment. So let's look at some of the core tenets of compartment. First thing is, each resource belongs to a single compartment. Each resource can only go to one compartment. It cannot go to multiple compartments. That's number one. Number two, resources can interact with other resources in different compartments. So in the previous example, this load balancer can be put in front of this compute resource, and this compute resource can use this block storage. It's completely possible. Even though they live in different compartments, they can interact with each other. You can always add and delete resources and compartments anytime. There are some restrictions around deleting compartments. They have to be empty, etc., but you could do that. Resources can be moved from one compartment to another. So it's a very flexible design. If you decide that there's resources need to be moved, you did an acquisition of a company, you want to group resources together, you could do that. And then resources from multiple regions can be in the same compartment. It's a very important concept. Compartment is a global construct, so you can still have resources in multiple regions worldwide, and they go into the same compartment, and you can have access policies, so people in different regions are only restricted to resources in their specific regions. You could do that. Compartments can be nested. We looked at that in the previous slide, 6 levels deep. You can give group of users access to compartments by writing these things called policies. That's one of the key reasons why you have compartments in the first place. And then you can analyze cost and assign budget for resources in compartment. Very important. You could roll up a compartment and you could see how much it costs to run the resources in that compartment. You could actually give a budget and say it should not exceed that particular threshold for a particular compartment. So that's it, folks. This module on OCI physical architecture, we looked at regions, we looked at what availability domains are, what fault domains are, um, availability domains isolated from each other, fault tolerant, unlikely to fail simultaneously. Fault domains are logical data centers within an AD, and of course you should use these constructs to avoid single points of failure and design and create highly available applications. Finally, compartments is a logical construct, is a collection of related resources. Why do you do that? Isolate your resources and control access to your resources. So that's it on this module on OCI physical architecture. Thank you for your time and joining this module. In the next module, we'll start looking at various OCI services. Thank you.